Okay, 6-5, part 2. Basically, all we're going to do today is just finish up what we were looking at yesterday. So, what you're looking at here, it kind of looks like a mess, but basically, what we are doing with this bell ringer, we'll finish up in one of the examples. So, recopy these in a later example later. So, we don't want to lose these examples or these integer possible roots. So basically, 5x cubed minus 24x squared plus 41x minus 20 has a lot of potential zeros because 20 has a lot of roots and 5 has 2 roots. So when we make our list, 20, if we look at our numerator up here, the top is all of our possible integer solution, or integer roots for 20. So 20 is 1 times 20, 2 times 10, and 5 times 4, 4 times 5. With all the plus or minuses, we got plus or minus 1 times plus or minus 20, plus or minus 2 times plus or minus 10, plus or minus 4 times plus or minus 5. And then on the bottom, we have plus or minus 1 times plus or minus 5, right? And that'll give us all of our possible integer or possible rational roots when we divide them. Now, I want to explain this list to you here because this list is a new type of list in comparison to what we had yesterday. So when we divide these, let's look at what we have here. So we have to divide everything on the top by everything on the bottom individually. So 1 divided by 1 gives us 1, plus or minus 1. I'm just going to ignore all the plus or minuses because they're with everything. 1 divided by 5 gives us 1/5. Okay, and then we go into the 2's. All right, 2 divided by 1 is just 2, and then 2 divided by 5 is 2/5. And then 4 divided by 1 is 4. 4 divided by 5 is 4/5. All right, so now this is where you can see some stuff is missing. So 5 divided by 1 is 5, and then 5 divided by 5 is 1. I didn't put a 1 here because look at the beginning of your list. It's already there. We don't need to write it twice. It's already here. So we don't need it again over here. 10 divided by 1 is 10. 10 divided by 5 is 2. Again, it's already right here. We don't need to list it again over here. All right. 20 divided by 1 is 20. 20 divided by 5 is 4. Again, I have a 4 right here. I don't need another 4 listed over here. So this is your list, all right? This is your complete list. It is a huge list of numbers. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. With the plus or minuses means there is a potential 18 lists of synthetic divisions that you could potentially need to try. Okay, we are not going to try all 18 of those. I'm going to try a couple of them, and then I'm going to jump right to the answer when we do this with our example later on. But again, this is not the best way of finding a zero, but it is a way that you could, I mean, this is like, if nothing else works, this way will get you a zero if a rational zero exists, okay? If a fractional answer, fractional zero exists. Now, if no fractional zero exists, if only irrational or imaginary or complex zeros exists, this process is going to be a complete waste of time. It won't even get you an answer. If you only have square roots or if you only have some kind of irrational answers, then this won't even get you an answer. And the only way you're going to be able to find a zero is by graphing it and finding out whatever that irrational is as far as what we're doing. That's the only thing you're going to be able to do. Okay, there may be other methods out there to find irrational roots that we're not going to explore, but basically for what we're doing, you would just graph it and find out what the zero is. So let's go into this one. We actually finished this one out yesterday, but we're going to just finish it out again. So we're going to start off by doing exactly what we did by listing our zeros. Now, like I said, we had already done this in the previous notes. So we would have plus or minus 1 for the top, and then the bottom, oops, let me restart this because it's getting messy already. All right, so plus or minus 1 for the top, and then on the bottom for 2, you would have plus or minus 1, and plus or minus 2. All right, so our potential zeros would be plus or minus 1 and then plus or minus 1/2. All right, and we did this yesterday. We found out that 1/2 worked, so I'm just going to, again, recopy the synthetic division for 1/2 that we showed yesterday or on the previous notes that worked. So again, just bear with me here for a second while I recopy this down here. We'll bring this 2 down. And 1/2 times 2 is 1. Negative 1 plus 1 is 0. 0 times 1/2 is 0. 2 plus 0 is 2. 2 times 1/2 gives you 1. Negative 1 plus 1 is 0. So we got a remainder of 0. So like I said, x equals 1/2 is a rational solution. Now the important thing here is that we read the directions, and in the directions it says find all the roots. So not just the rational roots now, we want all the roots, all the answers, all the solutions that find this to be 0. So not only rational, we want the irrational, we want the complex, we want every solution to this. So we're going a little bit further than what we did in the previous notes. All right, so let's finish this out now. We have our rational root of 1/2 that we got yesterday. So 2x squared plus 2 equals 0. And again, I did finish this out in the previous notes. I'm just going to do it again because I forgot that it was on these notes that we were actually finishing this out. So I'm just going to do it again. Move the 2 over. That's gone. We're ending up with 2x squared equals negative 2. Divide by 2, divide by 2. And again, if you watch the notes, you already know how this is going to end because like I said, I forgot I was actually finishing this out on these notes. So I got a little bit ahead of myself. No big deal. You get to see it twice. Square root, square root. So x equals plus or minus I. So that's going to be your square root. Okay, so x squared equals negative 1. Take the square root of both sides. Anytime you do the square root, you need your plus or minus. And the square root of negative 1 is I. So you get plus or minus I. All right, so now we found all the roots for that one. Again, example 2. This is going to be our last example because, like I said, I'm going to go through, I'll go through a couple of them, and then I will just give you the one that actually works, okay? And then we'll finish this one out. I'm going to finish this one out using the quadratic formula, but there is one rational root that works. So like I said, there are 18 potential roots here. One of these works, okay? You can bounce around and just say, well, maybe I'll try 2 and then 5 and negative 4 and 20 and, you know, just bounce around. I would never suggest doing that. I'm personally, I like doing it systematically. 1, negative 1, 1/5, negative 1/5, 2, negative 2. You know, that's how I would suggest doing it. If you want to bounce around, you might just happen to guess the right one right away. But that's, I mean, maybe you're just good at guessing and you might guess it correctly the first try. I don't know. I don't know. I would never suggest doing that though, but that's just me. So I'm going to start off with 1. All right, so again, synthetic division, 5, negative 24, 41, and negative 20. Now, if you are not very good, we are dealing with some bigger numbers here. So if you're not very good with your adding and multiplying with your integers, you may want to break out your calculator and follow along here. So I'm going to bring the 5 down. So 5 times 1, we're only multiplying by 1, so that shouldn't be the difficult part, but maybe the adding over here might be a little tricky for you. So 5 times 1 is 5. Okay, and then we're going to do negative 24 plus 5 in this next row here. Okay, so negative 24 plus 5 gives you the negative 19. Negative 19 times 1 is negative 19. Okay, and then 41, either you can look at it as either plus a negative 19 or minus 19, however you want to do that. Doesn't really matter, but that's going to give you 22. 22 times 1 is 22. And negative 20 plus 22 gives you 2. As soon as you realize this last number is not a 0, you can stop. Okay, that's all we're looking for is a 0 here. So once we know it's not 0, we know that it's not our answer, and we're done. Okay, we just drop it and move on. All right? No sense in wasting any time on it if we know it's not our answer. So if we go on to negative 1, let's see what we get here. 5, negative 24, 41, negative 20. Bring the 5 down. 5 times negative 1, negative 5. So we get negative 29. Negative 29 times negative 1. That's going to give us a positive 29. 41 and 29 is going to give us 70. Times negative 1 is negative 70. No way we're getting a 0 there, so I'm done. Moving on. That one's out. 1/5. All right, these are going to be the really tricky ones here when we're starting to deal with fractions now. So those of you that are not strong with your fractions may want to definitely think about breaking out a calculator now. And you can certainly change these to decimals. Like if you want to use, instead of 1/5, if you want to use 0.2, you can use 0.2. Use that in your calculator instead of 1/5. That's fine. Doesn't really make a difference. Because remember, all we're looking for is that 0 at the end. So, all right, so bring down the 5. 5 times 1/5. Well, this is going to be nice here for a little bit. That's just a 1. Negative 24 plus 1 is negative 23. Now it gets messy. All right, so negative 23 times 1/5 is, I mean, if you're using decimals, you can leave that as whatever that is as a decimal. I mean, a fraction is just going to be 23 over 5. Or mixed numbers. I don't even know what that would be. So it doesn't really make a difference. I just left it as negative 23 over 5. Just because I like improper fractions. And then add your 41 there. And that's going to give you 182 over 5. Multiplied by 1/5. And that's just going to make that a 182 over 25. I think it's pretty clear to see here that we're not going to end up with a 0. And that is basically where you can stop there, right? You end up with 318 over 25, negative 318 over 25. Either way, not 0. Okay, so one more. I'm going to do one more here, okay? And then I'll give you I'm going to do the negative 2/5. We'll do one more. I don't want to make it too easy and give you the answer right away. So I'll do one more here. We'll struggle through one more, and then I'll give you the answer. 41, negative 20. Just to get some practice here with our fractions and adding and multiplying fractions or decimals or whatever. Just to get a little bit of practice here. All right, so 5 times negative 2/5 is negative 2. Add those together, we get negative 26. All right, negative 26 times negative 2/5 gives you 50. Let me look here. I'm trying to look at my notes. 52 over 5. Plus 41 is 257 over 5. times negative 2/5. It's getting worse. Negative 514 over 25. Again, no way we're getting a 0 here. I'm done. I'm not even going to finish that one. All right. Okay, so here's the answer. I'm going to save us the trouble here now. Okay, 4/5. As long as I didn't mess up when I did mine. 4/5 should give us the answer. All right. So let's check it here. Make sure I didn't mess up when I did mine. You should get a 0 here for the remainder. Hopefully I didn't mess it up. I'm gonna do it here. I'm gonna do it all over again. I'm not gonna look at my notes on this one because I want to see if I messed up when I did mine. So let's check it here. I'm gonna scroll this up. So hopefully you guys got that one down. All right. So bring the 5 down. 4/5 times 5 gives you 4. So negative 24 plus 4 is negative 20. All right, I like it so far. It's giving us some nice numbers here. Negative 20 times 4/5 gives us a negative 16. All right, so 41 minus 16, that gives us 25. And then 25 times 4/5 gives us 20. Good. All right, so we got it. Add those together, we get 0. All right, good deal. So now we're in business here. We got a 0 for the remainder. This stuff right here, we have 5x squared minus 20x plus 25. And again, equals 0 that has nothing to do with this 0 right here. It just has to do with the beginning problem being equal to 0. All right. It has nothing to do. This is the remainder of 0. It has nothing to do with being equal to 0. All right. Now, so we know that one of our answers is 4 over 5. Okay. X equals 4 over 5. That's one solution. Now what we're going to do is we're going to take this part right here, 5x squared minus 20x plus 25. We are going to find out what are the other two solutions. Do we have real solutions? Are they imaginary solutions? Complex solutions? Rational? Irrational? What do we have here with these other solutions? And basically what I'm going to do is I'm just going to use the quadratic formula. But before I do that, I always want to factor out or divide out any common terms here, right? Or least common multiples. So these are all divisible by 5. So I'm going to divide everything by 5. So x squared minus 4x plus 5 equals 0, right? So x squared minus 4x plus 5 equals 0. All right, now, there's no way to factor this. I know some people might be looking at that and thinking, well, if I take a negative 5 and a 1, negative 5 plus 1 will give me 4x. Well, yeah, that's true, but negative 5 times 1 doesn't give you a positive 5. That would give you a negative 5. So if this was a minus 5, then yeah, we'd be in business right there. We could take that, we could factor that really nicely. It would work out great, and we'd be good. But that's not the case. So we're going to have to use quadratic formula. And that kind of tells me that maybe these are imaginary, but they're definitely irrational. We're not going to have any rational solutions here. So quadratic formula. First of all, I'm going to make my list here. So A is 1, B is negative 4, and C is 5. All right, so I'm going to jump into my quadratic formula here. X equals negative, B is negative 4, plus or minus square root of B squared. Negative 4 squared minus 4 times A times C all over 2A. So 2 times A is 1. So let's clean it up. X equals double negative there gives us 4 plus or minus Square root of 16 minus 20 all divided by 2. So 4 plus or minus square root of negative 4 all over 2. So 4 plus or minus 2I over 2, which will also reduce. These are all divisible by 2, so 2 plus or minus I. All right, so that's our other two solutions, and those are imaginary. But again, we wanted to find all the solutions, so those are going to be part of our final answer with our rational solution up above that was 4/5. So we're going to include them all together. Our final answer here, so x equals 4/5, was rational. We don't need to separate them or anything like that, or identify them as rational, irrational, imaginary, whatever. We're just going to put them all together here. There's our final answers for that problem. Okay? And again, if you went through and tried all of those, that may have taken you a while. That's why, if we had been in the classroom, I would have definitely had some of you try some of these, and we would have spent a little bit more time on this problem. But basically, doing this in the video and stuff like that, I wasn't going to go through all those and everything like that. So I wanted to try a few of them, but then basically just jump to the final answer. So, yeah, basically just wanted to run through a couple of those problems and just show you how to go through finding these when, that this is basically your last effort. There's no other way to find a zero, and that's why it's kind of time consuming, but it is a last resort if you have no other way of finding a zero for or a solution to a polynomial equation. So again, try those examples, try the homework problems, and let me know if you have any questions.